Okay, in this video we're going to have a look at acids and bases and neutralization and how we use indicators to help us identify acids and bases. So the first point we'll start with is looking at different types of indicator here, and these are the colours that they turn in acids and bases. Okay, so phenolphthalein, you see here in acids it's colourless and it becomes pink in base. Methyl orange is a red in acids but then becomes yellow, and litmus is red in acids and becomes blue. So these colours you need to learn, you need to have a way of remembering them so that you can refer to them in an exam. In terms of neutralization, okay, neutralization is represented by this general equation. So you have an acid and a base makes a metal, salt and water. These are done in green because we know that pH 7 with universal indicator is green, and these are neutral. So the salt and water become neutral, acid and base form a metal, salt and water. So here's an example of one of those reactions. So I've taken hydrochloric acid and we're reacting it with sodium hydroxide. Now we said it got to make a metal salt. The name of the salt depends on the acid and the base that we've got in here. So you can see because we've got hydrochloric acid, we're going to make a chloride salt, and sodium hydroxide is going to give us a sodium. It's going to be the metal part of the salt's name. So sodium chloride is the salt, and then as always we get the water. In terms of doing this as an equation with formulas in, then hydrochloric acid is HCl. Here is my sodium hydroxide. Notice that again I've used the colours to see where they come from. So these are going to combine to form sodium chloride, and there is the water. What I'm going to do now is go through this equation and I'm going to show you where the ions are in here. So hydrogen is a H plus ion. Then we have a negative chloride ion. We have sodium is Na plus, and a hydroxide is OH minus. On this side as well, we've got sodium is Na plus, and the chloride ion is Cl minus. Now water, it's a covalent compound, it doesn't have any ions, so I don't need to write any charges in here, but these all contain charges, they're all ions. If you look carefully, you will see that the chloride ion is a Cl minus ion, and over here the chloride ion is still a Cl minus ion. So these two ions haven't changed, therefore I can remove them from the equation and I can call them spectator ions. The H plus doesn't exist here as H plus, it's part of the H2O, so that has changed. I'm going to leave that in the equation at the moment. If you look at the sodium hydroxide, Na plus is Na plus, so that hasn't changed. We can get rid of that. Hydroxide ion has become water as well, so that has changed. Here it's an ion and now it's part of a molecule of water, so I'm going to leave that in. So that means this equation for neutralization of the acid comes down to H plus OH minus is left here, and then I've got on this side H2O. So this equation is the ionic equation for the neutralization of acid with a base to form water. And you need to know this, you need to learn this, and you need to understand how we form this by removing the spectator ions from the neutralization equation. And that then links in with this. So if you have your pH scale, working up from 1 to 14, if we start at this end, we're going to have a high concentration of hydrogen ions. So that gives us a low pH value. And as we add hydroxide, these two are going to react to become water. Water is neutral. So that means as we start to remove the hydrogen ions, the pH will start to increase. Until up here, when we get to the high pHs, 12, 13 and 14, we've got a very, very high concentration of hydroxide ions. So this allows you to see how the pH changes due to this reaction as we start to neutralize and then go beyond neutral, we have an excess of hydroxide ions.